Okay, Mr. Flowers, you ready? Check this out. Remember on the first example we did, I said, watch out. If that's a negative right there, you gotta watch out. And that's what's going to get you in trouble. So the LCM is still not too bad. It's 12, right? So 12, that's 3 times 4. This one's 4 times 3. And we can just write 12 on this one, right? Okay. That reduces. We're left with 4. Oops, we're left with 4 times that. So thing is, you got to make sure you multiply by the whole thing. So 8x más 4. All right. Here's the problem. This is really minus all of that.
Do you change it?
Yep. So it's really going to be minus 18x plus 3.
Oh God, I didn't get that. Oh, that's going to be difficult.
Yeah. Now.
Gotta be careful with that.
Right. So you could do it like this. You could change it right here.
Why did you put 4 and 3 like next to plus 1? Minus 8x plus 1. 4
Like right here?
You were multiplying it 4 times 3?
Well, because the LCM is 12, right?
Okay, to get the...
Yeah, so to get rid of all the denominators. Yeah. So that negative sign right there. Yeah. Okay, now this might seem like a joke, but that negative sign, when these are called rational equations, when you're subtracting them and you have to get a denominator like this, that minus sign, it's called a biatch. That's a strict mathematical term, by the way. Like really.
So that's what the whole joke is?
That's not even a joke. That's called a biatch.
I know, but when they say it like in a movie.
Oh yeah, that's a math reference.
Oh, it's a math joke.
Yeah.
All these years.
Okay, so this one's easy though, right? Because that's just negative 5. And from there, you're home sweet home. You just got to be careful with your signs. Like, okay, don't do this. This would be embarrassing. Don't do this. Like, here's what people do all the time. They're like, oh, look, this is going to be wrong, okay? They're going to like, oh, 8, and I got to subtract 8x. So they do this. And what they actually did is they subtracted 16x from one side and nothing from the other. It's no longer equal. These are on the same side, so you can just rearrange it. They like, as long as you keep the signs with whatever, it's the same as this. This marker's dying.
Why is it negative 5?
Because the 12's reduced and it was just negative 5.
That was the problem, was negative 5?
I thought so. I hope so. Yeah, negative 5. No wonder you got it wrong.
No. No wonder it's not going to get it.
Yeah, I see. Well, you just make up your own problems. You just rock with those. It's all right, dude. It's good. All right. So that's okay. We still got. I think you still get the idea, right? Like the negative and all that. And then I normally would not write this step. Like that seems like extra work to me. Yeah, I just go like, well, look, that's 8 minus 18. That's negative 10.
Yeah.
And then that's 7. And equals negative 5. So then that's negative 10x equals negative 12. All right, so you got to reduce. That is going to be, because you're going to divide both sides by negative 10, right? Negative divided by a negative is positive. And bless you. And make sure you reduce. Done. What do you think, Edgar?
I think that's maybe it's making it easier.
Does this get a... Does it deserve that? Ivan, you got questions about this one? Yeah, okay, Shukis. No?
No.
Okay. Okay, last one.
Be careful with the biatch.
That's right, you gotta watch out for the biatch, it'll get you.
Yeah, because somehow I end up putting the negative sign. I didn't put it on positive.
Yeah.
But it didn't affect the answer, because somehow I knew it was a positive sign, but I just left it as negative, so it's gonna bring me a
I
lot
think
of trouble.
I think you got lucky because there was another
Yeah, I
negative.
got lucky.
There was another negative somewhere else, and they kind of
Yeah,
the
and
mistake.
I think I totally missed it because I don't see any negatives on the one I did.
Yeah.
I still got a six,
Yeah,
six or
you
five.
made like the same mistake twice with the negative, and it canceled
Yeah.
itself. So yeah, that's just fortuitous. That's just good luck right there. Okay, now this one we were talking about. Me and Mr. Flowers and I were talking about, right? And this one, yeah. This one right here, the LCM is 20. 20. Right? Yeah. But we don't want to write like 4 times 5 because it won't be obvious how it reduces. But we do have to multiply everything by 20, and it's also different because there's 2 terms on each side, so we got to make sure we do all 4 terms by 20. So this one I can just by 20 because there's nothing going to reduce, but this one I would do times 4 times 5. This one times 20, and this one times 2 times 10, because that's how it's going to reduce. That makes sense how I like, because that's really the trick right there. Like that's the thing that's going to make everything reduce, and then life gets easier.
Yeah.
There are other ways to solve these problems that they're ugly and they're difficult, and we want to keep life simple. We want to use it's called the KISS method. We want to keep it simple, stupid. You heard that before, Ivan?
No.
Yeah. Sometimes people think like sometimes people think it's an insult, but it's not. It's not talking about the stupid. Is just like keeping it simple. It's not about anybody. It's about me. All right. This reduces, and we're left with 2y. Good? Good so far? Yep, 240. Edgar, we're doing good.
Yes.
Okay, now, this one sometimes seems backwards because people are in the habit, excuse me, of moving the unknown to the left side of the equal sign.
Yeah.
But that makes this more difficult. You'll end up with a
It's
negative.
always better to go for the positive one, right?
Yeah, you
like
want-
let's say that like -2, and then it was -2, and then or -5, and then +2.
You want to move the smaller one,
Yeah.
the one with the smaller coefficient. So 2, like if you do that, it's going to end up, your life will be good. It'll be best. Yeah. So you want to subtract this one because it's smaller. So you're going to subtract 2y. And at the same time, we can also subtract 240 from both sides. Like all at once. And here's one thing that's really, really tricky. These are actually equal, right? And it should be. Like the thing in blue, it should be equal. If it's not, then you didn't do it right. But here's the thing that's really tricky is, like we do algebra, we write algebra in this direction from left to right. But then when we do inverse operations like this, now all of a sudden we're doing math up and down like in a column. Like, this is how we write algebra most of the time, but then when we do inverse operations, then we all of a sudden write it like this. Do you see what I mean? So that's 0. That's what happens. It just makes 0, so it's gone. Whoa. Edgar, how do you say big 0 in Spanish?
The what?
Oh,
Big 0.
Gran cero.
cero grande.
Isn't that another way?
The big 0.
I know the one you think about.
Oh.
Negative 120 equals.
Oh,
I was like,
Yeah,
processing
me too.
too. Then I got it and I was like, oh.
People, yeah, alright. Divide by 3, divide by 3. And there you go.
I got stuck because I thought you couldn't change like the one you choose.
Esos 2 problems make
So you did 2 times 10.
completely understand.
I thought you were gonna use 2
Yeah.
times 10 for all
A mí
of them.
también.
But when I got to the 6, I had 2 times 10.
I see.
And same with the 4.
I see. Yeah. So it's still multiplying by the same thing. You're just writing it different, right?
Yeah.
Yeah. All right. Cool. Other questions?
See, I give him like 30 cents.